This week's topic is the reason for the seasons. To start, let's refresh our memory about a couple topics we've already learned. First, our planet can be divided into two hemispheres, north and south, and the dividing line between them is the equator, which is 0 degrees latitude. Second, we know that Earth's rotation causes celestial objects in the sky to appear to move counterclockwise around Polaris at a rate of 15 degrees per hour. Since those objects are not actually moving across our sky, we describe their movement as apparent motion. This week we are going to focus on just one of those celestial objects, the Sun. The basic apparent motion of the Sun is that it rises on the eastern horizon and then climbs higher in the sky in an arc-shaped path. When it reaches the highest point in its arc, we call it solar noon. Finally, it descends down the other side of the arc and sets on the western horizon. An observer's latitude changes where the Sun appears at solar noon. An observer in the northern hemisphere must always look to the south to see the Sun at solar noon, while a person in the southern hemisphere must always look to the north to see the Sun at solar noon. This is because the Sun's direct rays always point toward the low latitudes, which means near the equator. You can figure out where the exact altitude of the Sun at solar noon will be using this formula. 90 degrees minus your latitude equals the altitude of the Sun at solar noon. For example, the latitude of Wayland, New York is about 43 degrees north. Since 90 degrees minus 43 degrees is 47 degrees, the Sun will appear to us at an altitude of 47 degrees above the southern horizon at solar noon. Unfortunately, all of the basic rules we've learned so far, sunrise in the east, sunset in the west, and the formula for solar noon, all of these are only true on 2 days of the year, which are the spring equinox and the fall equinox. All of the other days of the year, the rules change, and that is because of the Earth's tilt. The reason for the seasons is Earth's tilt. The reason for the seasons is Earth's tilt. This is the number one misconception in Earth science. People think that it is caused by something else, but the reason for the seasons is Earth's tilt. Here's how it works. The Earth's axis is tilted 23.5 degrees. As Earth revolves around the Sun, its tilt doesn't change. It is always oriented in the same direction, which happens to align with the North Star, Polaris. This is called parallelism of the axes. On the spring equinox, March 21st, the direct rays of the Sun are focused on the equator, 0 degrees latitude. On the summer solstice, June 21st, the North Pole is tilted toward the Sun, and the direct rays of the Sun are focused on the Tropic of Cancer, 23.5 degrees north latitude. On the autumn equinox, September 23rd, the Sun's direct rays are focused back on the equator, 0 degrees latitude. And on the winter solstice, December 21st, the North Pole is tilted away from the Sun, and the Sun's direct rays are focused on the Tropic of Capricorn, 23.5 degrees south latitude. You may be wondering, why do we keep talking about direct rays? The Sun's energy is called insolation. The energy that is received at a certain location on the Earth is described by its intensity. If the insolation is coming from a high perpendicular angle, it has high intensity, which means the Earth receives more energy at that spot. If the energy is coming from a low angle, it has low intensity, which means the Earth receives less energy at that spot. The direct rays of the Sun have the highest intensity, so wherever they shine on Earth, it will be warmest there. That's why it is warm at the low latitudes near the equator and cold at the high latitudes near Earth's poles. The Earth's tilt changes the Sun's apparent path throughout the year. As we discussed, on the equinoxes, the Sun rises directly in the east and sets directly in the west. The altitude of the Sun at solar noon is equal to 90 degrees minus your latitude. So in Wayland, New York, the path of the Sun would look like this. The Sun rises directly in the east. At solar noon, the Sun's altitude is 47 degrees above the southern horizon, and the Sun sets directly in the west. On the summer solstice, June 21st, everything, sunrise, solar noon, and sunset, are shifted 23.5 degrees to the north. In Wayland, New York, the path of the Sun would look like this. the sun rises 23.5 degrees north of east. At solar noon, the sun is 23.5 degrees higher in the sky, and 47 degrees plus 23.5 degrees is equal to 70.5 degrees, and the sun sets 23.5 degrees north of west. Notice how long the sun is in the sky. That's why days are so much longer in the summertime. On the winter solstice, December 21st, everything, sunrise, sunset, and solar noon, are shifted 23.5 degrees to the south. In Wayland, New York, the path of the sun would look like this. The sun rises 23.5 degrees south of east. At solar noon, it is 23.5 degrees lower in the sky, and since 47 degrees minus 23.5 degrees equals 23.5 degrees, the sun's altitude would be 23.5 degrees above the southern horizon, and the sun sets 23.5 degrees south of west. Notice how briefly the sun is in the sky. That's why days are so much shorter in the wintertime.